Okay, I'm going to take out the electrode connected to the negative terminal of the battery, and you may be able to see a reddish substance plated onto the electrode. Okay, so we believe that that reddish lumpy substance collected at the negative terminal, at the graphite electrode connected to the negative terminal battery, we believe that is in fact copper metal. And so we have discovered copper, and this process was used over and over again, especially in the early, in the first two decades of the 1800s, when over 20 elements were discovered. So it was just a wonderful time in chemistry, and so that actually answers that one question that we posed in the launch. Where are the elements? So indeed, the suspicion of chemists were correct, and geologists. These elements were kind of locked up, bonded in compounds and minerals and ores throughout the earth. So the game, or the strategy, was let's go find some minerals, let's go find some ores, and just run electricity through it. And voila, out pops another 20 or 30 elements in the first two decades of the 18th century, of the 1800s. So yeah, pretty cool. And so this kind of answers one of the questions we posed in the launch, and that's where are the elements? They're on Earth, they're in the ores, and they're hidden in the ores, minerals, and rocks. We still haven't answered a couple questions, so I'll just say those right now. And the one question still standing is, why are compounds or minerals so different than the elements that make them up? So why is copper sulfate so different than copper? So we'll just leave that question for now. And then another question that's still unanswered is, why do metals prefer to react with non-metals more than other metals? So copper, osmium, titanium, tungsten, sodium, calcium prefer to react with non-metals like oxygen, selenium, carbon, chlorine, fluorine, more than they do with each other. So just a question at this point in time to keep in your mind. So the third thing I want to talk about is the piece entitled "Why Copper Metal, Not Hydrogen Gas" in the landing section of the course platform. So the section is "Why Copper Metal, Not Hydrogen Gas." And I want to talk about this for a moment right now because it gets into some deeper chemistry concepts. And we won't come to any grand resolutions right now, but I want to frame this question, why copper metal and not hydrogen gas? And this question arises from a comparison of this lab where we had copper sulfate dissolved in solution, and a lab from chapter 3 in the first course called Chemistry of Atoms. And in that lab, you may recall, we ran electricity through a solution of baking soda, and that's where we discovered hydrogen and oxygen. Baking soda, of course, the formal name is sodium bicarbonate. So let me just frame the question. Why does copper plate or collect on the negative electrode in this experiment, but sodium does not plate on the negative electrode in this experiment? Hydrogen bubbled or collected at this negative electrode. So again, why copper, which was in solution, plates out, and why not sodium, which is in solution, and why doesn't that plate out? So there's just two ideas that we can go on at this point in time. And keep in mind, chemists at the time in the early 1800s had no idea either. So the only ask of you is to begin to hypothesize on why this must be the case. So there's two ideas to go on, and so I'll share those with you right now. One idea is, clearly it has to do with how these two elements, copper and sodium, respond to electricity. So the interesting chemistry in these both experiments is happening at this negative electrode. So what is it about copper that it sees these electrons being pumped into solution and says, great, hello electrons, I'm now going to convert from being in solution to being a pure element? And why does sodium say, hey electrons, great, I see you coming in, but I'm not going to come out of solution and become a pure element. I'll let hydrogen do that. So the response to electricity or electrons is the first thing to consider. The second thing to consider is just the fact, it's a fact, that evidently copper likes to be an element more than sodium. So if copper has a chance to be an element it will become an element. If sodium has a chance to become an element, it will be less likely to become an element. So just to rephrase this second idea, copper, evidently likes to be in its elemental form as opposed to in solution or in a compound more than sodium. And to twist that around, sodium likes to be in a compound or in a solution more than it likes to be in its pure elemental form. So those are the two ideas to think about to answer this question, why copper and not sodium? And lastly, let me just encourage you, if you can, to dive into the deeper dive section. There are three really cool parts to this. One is it's interesting to note that there are still elements being discovered. So certainly the first 2 decades of the 1800s were this amazing time in chemistry where there's a flurry of new elements being discovered every year or multiple every year. We're still in the case. We're still discovering or trying to find new elements. So that's one interesting thing. I touched on this earlier, but there's a little write-up on the logic of determining definitively if something is an element or not. So check that out. And lastly, interesting anecdote on the discovery of aluminum. So aluminum, which is so common today, aluminum foil, it's everywhere, and it's aluminum cans, and it's relatively inexpensive. For a period of time after discovery, it was the most valuable element on Earth. And so a quick read about that is, a quick write-up about that is in the course platform. So check those out, and I'll see you soon.